Hello everyone, let's talk about another hard problem on Leetcode today, word break 2, Leetcode 140. In this, we are given a string S and a dictionary of strings wordDict. We add spaces in string S to construct a sentence where each word is a valid dictionary word. Return all the possible such sentences in any order. Note that the same word in the dictionary may be reused multiple times in the segmentation. So then they have given some examples. First example is cats and dog. That's a input string, and then there is a word dictionary which is like contains cat, cats, and sand, dog. And then we can form like cats and dog, and then we can also form cats and dog, even though this doesn't look like a valid sentence, but this is valid because the problem only states that the words in the sentence should be coming from some dictionary, and that's why it's valid. So similarly, they have also given example 2, pineapple, pen, apple, and then they have this given these words, and based on this, these are the possible sentences that we can form. And they also say that the word dictionary word can be reused, so it doesn't matter if it's like so in this case, we can see that pine, apple, pan, apple is okay because apple has occurred 2 times, but that is totally fine because it's a word from dictionary and we can reuse it multiple times. Now let's jump into the solution space. There are multiple ways to solve this problem. One of the easiest approach is we can do backtracking. So what we can do is we can create the substring from the string and then check if the substring is present in the word dictionary. If it is, then we can break that from the string and then start the same process for the remaining string. And we will continue to do that till we reach the end of the string. And another approach can be we can reuse the solution from word break 1, which is dynamic programming. It will be more space efficient when it comes to space complexity, but in terms of time complexity, it will be the similar approach. We can also use some other data structures like try or something, which can also help us optimize a bit when it comes to the lookup. But overall time complexity will stay the like in the exponential way because we need to get the outputs. Rather, we don't need like whether the word is breakable or not, what are the number of ways a word can be broken. This is where I think dynamic programming or some other solution can come in. But here we just want to have the actual sentences that can be formed, and that's why I think backtracking is our best bet. Now let's look at state space tree for word break 2 backtracking algorithm. So in backtracking, we try to search the different solutions, maybe using depth first search or some other approach, and then we backtrack to the last valid path whenever we hit the dead end. Suppose we are given this string s as cats and dog, and wordDict as cat, cats, and sand and dog. So what we will do is we will try to generate all the substring from this word, and then try to see if the particular substring is in the word dictionary or not, and then do the same thing for the remaining substring. So we will see, is C in this word dictionary? No. CA is also not in word dictionary. Then we get cat, and luckily it is in the word dictionary, so we will go to the next thing. So our remaining string will be sand dog, and now we will start the same process of DFS at this level as well. So we will try to form all the substring from sand dog. So we will see S, SA, SAN are not present. By the way, so the notation I've followed is like red color means it's not a valid path and green means it's a valid path, and we will try to go down the DFS route. So again, we find sand. Now the remaining string is dog. So what we will do is like we will see is D or DO present in the word dictionary. The answer is no. Then we get dog, and then the remaining string is empty. That means we have reached the end of the string, and now we can return and see if there are other possible solutions. So we will come up and then we see, oh, is it the cats is also there. So now we will go down this path as well. It will be like and dog and then an and so luckily and was one of the words present in the dictionary, so we will break it here. Then we look, is dog breakable, and answer is again yes, like we already saw it here. So do are not present, but dog is present. So and we have reached the end of the string, so this is also our answer. Now we backtrack, and now suppose we look for CATSA, catsa, but this is not present, and similarly catsan is also not present in the word dictionary. So we will continuously break out of all these iterations, and eventually only two answers will remain, which is cat, sand, and dog, and cats and dog. In terms of time complexity, as you can see this, suppose the string length is n, then at each step we are trying to create substring from the string, and then choosing whether we can go down that path or not, and that will require like 2 to the power of n time complexity. And in terms of space complexity, we are using O of n space, because if you look at one particular depth of the state space tree, we will be only storing n strings at maximum when we are going down. Also, in terms of Java programming, they have given list of string as a word dictionary, but we may also like to convert it to the set of string, because it lookup operation in set is O of 1, so that will be faster. So in that case, it will be like the space complexity will be O of n plus m, where n is the length of the string, and m is the length of m is the number of words in a dictionary. Now let's jump into the code part. So first thing we will need is list of string that we will return as an answer. Then we will just write our DFS logic. So first thing, again, we will pass is string s new hash set, because it will be faster for querying the string in the dictionary. And then we will also pass the current index, where we will start separating or partitioning the string from. So we can start with say 0, and then we will also pass in the answer, and we will also pass in sub answer, which tracks words in the current path. Now the DFS logic will be very similar to what we had in say subsets or some other solutions that we have seen. So we will just say, okay, word set is the input. Then we will need the index of this index of the character, where we will start the partitioning of the string. Then we will also take in our answer, and we will also take in our sub answer. And once we have it, now the first condition is like our base case is once we reach the end of the string, right? So in this case, if our sub answer is not empty, in that case we will just do answer.add, and then we can just do string.join to join the list of the string by spaces, and then continue and do our actual DFS, right? So it will be for, so yeah, then I think what you have to do is like we have to start creating the length of the different strings. So it will be from idx plus 1. We will just run the for loop till the end of the string and create a substring out of it. So we will create a substring from whatever index we have to till the end of the string, incrementing it by one. If at any point our set contains this substring, in this case we will just add it to our sub answer. Why is this the problem? Because it should be here. Good that we saw it now itself. Yeah, so sub answer dot add the substring to our path. Then we will just do the DFS again for the remaining substring. So it will be set. And now I will pass I, because we have successfully partitioned the string from index to I. Now we will do it from the I to the remaining end of the string again. So it will be answer. Then we will also pass answer and sub answer. But if this doesn't work, then we should also have a backtracking strategy where we will just remove. And because we add this answer to the end of the list, so we will just remove it also from the end of the list. That's it. I think once we are done, I think this should be good enough. Yeah, I should also add a return statement here maybe, because our DFS is over at the end of this. And that's it, I think. Now let's run this code. Okay, there is some issue here, illegal start of the expression. So it says that, I forgot to add new here. Maybe that's why. Then it also complains that on line number 14, it should be semicolon, not comma. So let's run it now. And I'm missing the return statement somewhere. Yes, I should be returning the answer. Cool. Now let's submit this code. Awesome. So as you can see, it's pretty fast. It just took 1 millisecond. I hope this was useful to you. And if it helps you, please like and subscribe. Please also comment if you want some specific problem to be addressed, or if you have some feedback for me. Have a nice time. Thanks again.